frosty winter day at the Zhukovsky Flight Research Center outside Moscow. Russian engineers and onlookers are reunited with a ghost from the past. In the mid-90s, two Cold War adversaries came together to conduct research into a supersonic passenger jet for the 21st century. NASA, Boeing, and the Tupolev Design Bureau have reincarnated the supersonic passenger jet, the Tupolev Tu-144, to obtain data on sustained Mach 2 flight. Computer models and wind tunnels can only reveal so much. Tu-144 flight tests augment this research by providing real-world data. To breathe life into the Kontkortsky, engines were borrowed from another Tupolev creation, the Tu-160 Blackjack. The Blackjack holds the record as the heaviest, most powerful combat aircraft in history. Its Kuznetsov NK-321s are the most powerful military engines ever flown. The Blackjack was the culmination of a long and difficult struggle to create an intercontinental bomber to match the West. When it appeared in the early 1980s, it was a great achievement in Soviet aircraft design. Yet its career was short-lived as perestroika signaled the end of Cold War defense spending. This is footage of a Blackjack bomber back in 1992. It's operating from the Zhukovsky Flight Research Institute, the same airfield chosen for flight tests of the Tu-144. Like Tupolev, Zhukovsky is a prominent name in Russian aviation. It's a name which set the direction of the Russian aircraft industry and the history of the Russian bomber. Nikolai Zhukovsky is the father of Russian aviation. Before World War I, he helped give Russia its own identity in a field dominated by Europe and America. In 1918, the new socialist government officially recognized his laboratory. It became known as TSAGI, the Central Institute of Aero and Hydrodynamics. At TSAGI, dozens of young engineers worked under Nikolai Zhukovsky. One of them was Andrei Tupolev. Early on, Zhukovsky had recognized Tupolev's talent and had put him in charge of his laboratory. At TSAGI, his genius was allowed to flourish. During the 20s, several projects were started under his direction. The aircraft he designed bore his initials, ANT. Tupolev's first large aircraft was the ANT-4. It flew in 1925 and was the world's first all-metal monoplane bomber. The ANT-9 flew in May 1929. It was a 9-passenger airliner which proved its long-range capability when it flew from Moscow to London and back again via Berlin, all in just 53 flying hours. For Andrei Tupolev, this set the stage for a litany of long-distance record breakers. In 1933, Stalin ordered Tupolev to design an aircraft with greater endurance than anything in the sky. The result was the ANT-25, a single-engine giant with a wingspan of over 111 feet. Stalin wanted the ANT-25 to break records, and that it did. In June 1937, it flew from Moscow over the North Pole to Washington State, a distance of over 5,000 miles. Just a month later, it flew from Moscow to San Jacinto, California. It took 62 hours and marked another world record. In 1932, the Union of Soviet Writers and Editors raised 6 million rubles to finance the construction of a massive aircraft carried the name of the Russian writer Maxim Gorky. Andrei Tupolev, who was by now the leading figure in Soviet aviation, was chosen for the job. In 1934, over 800 technicians began work under his supervision. Other aircraft design bureaus and representatives from hundreds of different Soviet institutions were subordinated under Tupolev. The result was the largest aircraft of its time. The Maxim Gorky had a wingspan of over 200 feet and was powered by 8 engines of 900 horsepower each. It flew for the first time on May 19, 1934. Soon it became the centerpiece of the Maxim Gorky squadron, making propaganda flights throughout the Soviet Union. The crew showered cities with pamphlets, broadcasted music and speeches, and even projected images on clouds. The Maxim Gorky made an impression beyond Soviet borders. It was the largest land plane of the time. It was faster than many fighters, and it could fly over 1,000 miles without refueling. For Russia's neighbors, its potential as a long-range bomber didn't go unnoticed. But just a year after it was built, the Maxim Gorky propaganda flights ended in disaster. It was destroyed when a biplane escort, attempting an unauthorized loop, crashed into its wing. By now, Tupolev had developed a reputation for record-breaking aircraft of great symbolic value to the Soviet state. But Tupolev wasn't limited to projects of propaganda. He was also commissioned to build weapons of war. Back in the early 30s, Tupolev unveiled his first 4-engine heavy bomber, the ANT-6. Some of the aircraft were converted to troop carriers, holding 30 fully equipped airborne soldiers. More than 800 were built, and together with the ANT-4, Tupolev's aircraft now comprised the largest strategic bomber force. In 1938, Tupolev was accused of treason and thrown into prison. In the Great War to come, Stalin would rely on a new generation of designers, men who would produce the fighters that would repel Germany's mighty Luftwaffe. There was Alexander Yakovlev, the father of Russia's great wartime fighters, the Yak-3 and the Yak-9. Semyon Lavochkin gained fame for his LA Fighter series. Mikoyan and Gurevich combined their efforts to create the first in what would be a series of legendary MiG fighters. And finally, there was Sergei Ilyushin, the father of the IL-2 Stormovik, the so-called flying tank which wrought havoc on German panzer divisions. Although the Stormovik is the aircraft that brought him fame, Ilyushin also designed the first successful Soviet medium bomber of the war. The DB-3 series, later called the IL-4, was a twin-engine design dating to 1936. Later versions had a slender glazed nose section with a hand-aim gun at the front. Andrei Tupolev's protege and PE-8 designer, Vladimir Petyakov, joined Tupolev behind bars during the war. Stalin was paranoid, but not foolish enough to let some of his brightest aircraft designers freeze in a Siberian wasteland. Both men were summoned to harness their skills at the so-called Prison Design Bureau outside Moscow. Early in the war, Stalin ordered the construction of a dive bomber. Tupolev's protege adapted one of his designs to create a high-altitude twin-engine fighter. The result was the PE-2. Stalin was so pleased with his new aircraft, he let the young designer out of prison. The PE-2 was based on a fighter design, and it was in the role of a light bomber that the Red Air Force harnessed the speed and agility of its new aircraft. Soon, the deadly new aircraft was brought to bear against German troops and tank divisions along the Eastern Front. The PE-2 was a sleek aircraft, reminiscent of the RAF's wooden wonder, the de Havilland Mosquito. It was not made of wood. Nevertheless, its two 1,100 horsepower Klimoff engines gave it an impressive top speed of about 330 miles an hour. The PE-2 had a crew of 3. Sitting next to the pilot was the navigator. The gunner sat in the back. Each crew member had an armored seat, and the aircraft's underside was armored below the cabin. Reaching out over German lines, the light PE-2 was vulnerable to anti-aircraft fire. Many of the planes were modified in the field. Most of them were given more armored plating, a dorsal gun turret, and extra machine guns. As German invaders became mired in harsh winter fighting, PE-2s swept down from above, providing much-needed close air support for its under-equipped Russian soldiers. One of 3 women's air regiments, the 587th, was equipped with PE-2s. The PE-2 was one of the workhorse medium bombers of the war, and by the end of hostilities it was joined by a host of other aircraft which had gained parity with its Allied counterparts. But for the Soviet Union, the great air battles of World War II were a sideshow. From the beginning, the struggle along a vast, bloody Eastern Front was a war which would be won and lost on the ground. Joseph Stalin didn't possess the legendary bombers used so well by his allies. This doesn't mean he didn't want them. The introduction of America's Boeing B-29 marked the beginning of the end of World War II. America now had a bomber of unmatched long-range, high-altitude performance. Throughout the war, Stalin repeatedly asked the U.S. government for a large 4-engine bomber to replace the aging PE-8. His requests fell on deaf ears. Then in August 1944, 3 American B-29s operating out of the Far East landed on Soviet territory after running short of fuel. The U.S. had presented Stalin with an unintended gift in the shape of the world's most advanced strategic bomber. By now, Stalin had forgiven Tupolev and restored him to his pre-war eminence. When the B-29s fell into Soviet hands, Stalin ordered Tupolev to copy the airframe. Only a year later, the Soviet copy was ready to fly. It was given the designation Tu-4. The bomber was a direct clone of the B-29. All of the castings were molded from the American bomber, right down to the rudder pedals, which bore the name Boeing. The West soon began its habit of giving nicknames to Soviet aircraft. All bombers began with the letter B. In 1947, Western authorities were shocked to see the first 3 Tu-4s flying in the Aviation Day parade. The new Soviet bomber would become known as the Bull. The Bull didn't enter service until 1949. That same year, America learned that Stalin had gotten his hands on something far more dangerous than the Boeing airframe. The Soviets had detonated an atomic bomb of their own. Suddenly, America's nuclear monopoly disappeared in a menacing atomic cloud rising over a desolate stretch of eastern Russia. A new war was looming. A war between East and West, where the threat of nuclear annihilation hung precariously along a thin line of diplomacy. The Cold War had begun in earnest. This is the Tupolev Tu-16. Because it's jet-powered, NATO gave it a 2-syllable code name, the Badger. It flew for the first time in 1952, roughly the same period as the American B-52. Although it didn't match the B-52's speed or range, it was a major step for Andrei Tupolev and the Red Air Force. Between 1952 and 1958, almost 2,000 Badgers were produced for the Red Air Force and the Soviet Naval Air Forces.
Сейчас, Андрей Николаевич, у нас первая задача.
The Tu-16 originated from Stalin's demand for a bomber to replace the Tu-4 Bull. A design competition was held between Andrei Tupolev's design bureau and the design bureau of Sergei Ilyushin. Ilyushin had gained favor with Stalin during the Second World War and was the man behind the Soviet Union's first jet bomber, the Il-28. In creating the Il-28, Ilyushin combined his experience of building twin-engine wartime bombers with borrowed jet technology from the British. All early Russian jets were copies of the Rolls-Royce Nene engine, which had been exported before the onset of the Cold War. Using two such engines, Ilyushin produced a tactical straight-wing bomber capable of traveling over 500 miles an hour at low level. The Il-28 was built in great numbers, and over 1,000 were exported throughout the world. The Il-28 had been a success, so when Sergei Ilyushin threw his hat into the strategic bomber competition, his design was simply an updated model of the Il-28. Tupolev's entry presented the military with a more cutting-edge design. It had swept wings stretching a distance of over 100 feet. Its two engines were recessed into the sides of the fuselage at the wing roots. The Badger had a crew of 6. 2 pilots sat in the main cockpit, with the navigator sitting in the glazed nose section. 2 of the crew were gunners, with the forward position operated from a bubble behind the cockpit. The rear gunner sat in a turret at the back of the fuselage. All of its defensive positions, which included a forward-firing gun, were also based on World War II ideas. But its highly swept wings and engine configuration brought Tupolev into the modern age. It was a contemporary of the legendary British V-bombers, and like the V-bombers, it was initially meant to carry nuclear weapons. The Badger carried up to 8,000 pounds of bombs in an internal bomb bay, but not all Tu-16s were bombers. During its long service life, NATO identified at least a dozen different variants from maritime patrol to electronic warfare. During the early 60s, the desire for long-range naval aircraft gave the Badger a new lease on life. Tu-16s were transferred to the Soviet Naval Air Service, becoming its first airborne missile carriers. The first variant was the Tu-16KS, often called Badger B. The Badger B was fit to carry standoff anti-shipping missiles, like the turbojet AS-1, which NATO called the Kennel. One of the more successful Badger variants was the tanker version, or Tu-16N. The tanker could hold almost 12,000 gallons of fuel. The hose was stowed on a large reel in the bomb bay. When it was time to refuel, the hose was let out through the starboard wingtip. With careful piloting, it would catch a drogue on the port wingtip of another Badger. Once in place, the tanker transferred 220 gallons per minute. The Badger N first took to the sky in 1963 to serve a new generation of Soviet bombers. But new Soviet bombers were fitted with more conventional refueling probes. And as this footage reveals, the unique wingtip-to-wingtip configuration could only be used to refuel other Badgers. This Tu-16 variant doesn't have the glazed nose canopy of the original Badger. The Tu-16K-10, also called Badger C, was developed to carry the deadly supersonic AS-2 Kipper anti-shipping missile. A search and tracking radar was installed in the nose section to guide the missiles for 150 miles. The Badger C first flew in 1958, but it didn't enter service with the Soviet Navy until the missile was ready in 1961. Once it entered fleet service, the threat posed by the Badger had an immediate impression on U.S. naval thinking. This is footage from the inside of a Badger C, as it's being escorted by a U.S. Navy F-14 Tomcat. A long-range interceptor, the Tomcat was purpose-built to destroy Soviet missile carriers like the Badger. In 1955, a civilian version of the Badger was designed, taking Aeroflot into the jet age. The passenger version was called the Tu-104. Not only was it the Soviet Union's first jet transport, it was the first passenger jet in the world to enter continuous service. Joseph Stalin ordered the construction of a bomber which could fly to the United States and back. Andrei Tupolev's son-in-law, Vladimir Myasishchev, took up the challenge. The ambitious young designer was given Stalin's blessing. He received special resources to build a factory and was allowed to poach engineers from several other design bureaus. The Bison was the Soviet Union's first real attempt to create a large jet intercontinental bomber. It first appeared at the Soviet Aviation Day flypast in 1954. The Myasishchev Design Bureau proudly dubbed their bomber the Mallard, Russian for the Hammer. But Myasishchev's Hammer didn't live up to its name. The Bison only achieved half of its intended 10,000-mile range. Soviet jet technology was yet to come of age. Bison could not fulfill Stalin's desire to fly to America and back. As a true free-fall bomber, it was obsolete almost by the time it entered service. Unlike the Badger, low ground clearance prevented the aircraft from ever carrying air-to-surface missiles. A few were produced, primarily for maritime reconnaissance and as a tanker for aerial refueling. This and other disappointing aircraft projects caused Myasishchev to lose favor with the Soviet hierarchy. Eventually, his design bureau was taken away altogether. Tupolev didn't make the same mistake. Back when Stalin demanded an intercontinental bomber, Tupolev realized that Soviet jet engines were not efficient enough to achieve the range Stalin was looking for. Instead, Tupolev looked to the turboprop. The turboprop engine was developed by the Kuznetsov Bureau. Kuznetsov benefited from the influence of German engine builders who arrived in Moscow after the war. In the early 1950s, they developed a turboshaft engine which drove a pair of counter-rotating propellers. The engine produced an impressive 12,000 horsepower. Tupolev rightly guessed that the engine-propeller combination was more efficient than the jets at the time. At the 1955 Moscow Air Show, Western observers watched a big, swept-wing aircraft fly overhead, one that was powered by turboprop rather than jet. At the time, NATO paid little attention to the new aircraft, focusing rather on the jet-powered Bison they had seen the year before. Western observers had no idea they'd just seen a prototype version of a bomber that would pose the greatest threat to NATO for years to come. It was the Tu-95 Bear. The Bear is an exotic-looking bomber. Most striking are the massive propellers, each over 16.5 feet in diameter. At maximum speed, all 32 propellers are spinning at 750 revolutions per minute, with the tips of the propellers moving at Mach 1.08. The first model Bear was a dedicated long-range strategic bomber. Its wingspan was nearly 170 feet, with a payload of almost 500,000 pounds, slightly less than America's B-52. From nose to tail, it stretched 158 feet. The Bear entered service in the late 50s. In an age when jet power meant everything, it stood out as a unique achievement. It was the only turboprop-driven bomber in the world to ever enter frontline service. It could achieve a top speed of over 575 miles an hour, 100 miles an hour faster than most engineers thought possible in a propeller-driven aircraft. With a range of over 8,000 miles, the Soviets now had a bomber which could reach the American heartland. Like Tupolev's record breakers of the 1930s, the most direct route for Soviet strategic bombers was over the North Pole. The long-range threat posed by the Bear bomber forced changes in America's defensive thinking. In the 1950s, the Air Defense Command was established to protect America's northern frontiers. It was comprised of 3 lines of early warning radar systems. If a Soviet bomber formation tripped the alarm, F-106 interceptors were sent to greet it. This is footage of F-106s escorting an early model Tu-95 along the fringes of U.S. airspace. As with the Badger, Andrei Tupolev built a civilian version of the Tu-95. In 1961, the Tu-114 entered service with Aeroflot and soon became the backbone of Soviet international travel. It was one of the most unusual-looking passenger planes to enter service. But its range was impressive, and soon it was making daily non-stop flights between Moscow and Cuba. The Bear's landing gear were made extremely long to allow clearance for its big propellers. Like all Soviet military aircraft, they were also made rugged enough to handle rough, unpaved landing strips. Aside from its basic design features, the Bear proved to be one of the world's most modified airframes. Over its long and distinguished career, it would enter service in at least 15 dedicated variants. The original Tu-95, the Bear A, was built to carry a 5-ton bomb load to a target 4,500 miles away. But as a conventional bomber, the Bear was quickly made obsolete thanks to surface-to-air missiles. Like the Badger, Tupolev modified his Bear to carry a variety of big standoff missiles. These aircraft are Tu-95 K-20s, known in the West as Bear Bs. The most obvious distinction is a sort of large chin jutting out from under the cockpit. When it first appeared, its pilots called it the duckbill. But inside was a lethal innovation. A long-range guidance system using I-band radar was used to scan the horizon for targets. Recessed into the bomb bay, a 10-ton, 50-foot-long guided missile was poised to launch. The Kangaroo, as it became known in the West, had tremendous standoff range and could carry a nuclear warhead. With the emergence of Bear B in 1959, the turboprop bomber was no longer obsolete. When the Kangaroo missile was first deployed, it was about 7 feet longer than the premier Soviet fighter of the time, the MiG-19. Soviet military planners quickly deduced that if a Bear B could launch a Kangaroo, it could also launch a MiG. Here, a MiG-19 pilot is about to be dropped from a Bear's bomb bay. The Soviets may have been inspired by the American Fighter Conveyor, or FICON program, of the early 50s. The U.S. Air Force experimented with dropping RF-84 aircraft from the B-36 bomber. It was an effort to give substantial range to fighter or reconnaissance aircraft. It appears from this rare footage that the Soviets had a similar idea in mind. Over time, the Bear B aircraft were updated to carry newer, more sophisticated avionics. The Bear G had an improved electronic warfare suite to handle targeting of a new generation of air-to-surface missiles. The deadly KH-22 missile could be carried in the belly or on the pylon under each wing. The Bear G also had an electronic intelligence fairing and cameras on each side towards the rear of the fuselage. But the most visible difference on the Bear G is the refueling probe. Unlike the Badger, all Bear variants had their refueling probes on the nose. The prototype first flew in 1975, and almost 50 of this variant remained in service until the mid-90s. The final missile-carrying version of the Bear was the Tu-95 MS-6, also called the Bear H. The Bear H's biggest giveaway is the shorter forward fuselage, which can be seen here from the side. The Bear H was first flown in 1979. The goal of Tupolev designers was to dramatically improve the aircraft's defensive capability. This they did. The aircraft was given full defensive avionics, jamming equipment, and chaff and flare dispensers. Various antennas under the nose and tail provided infrared warning. One of the most prolific variants was the Tu-95 RT, also called the Bear D. The Bear D entered service with the Soviet Navy in 1964. Its main role was maritime reconnaissance. It also relayed target information to Soviet submarines and cruise missile ships. The Bear D's most distinctive feature was its two large radar domes, a small one under the nose and a much larger one at the bomb bay. The smaller radome was used for submarine or ship-launched missile guidance. The larger belly radome was used for targeting ships over the horizon. Two large dorsal antennas were used to link up with Soviet reconnaissance satellites and communication centers back home. Because of the Bear's legendary range, Soviet crews spent much of their time in the company of American fighter escort. Here, a group of F-15 Eagles take pictures of the Soviet bomber. This is the Tupolev Tu-22M, the Soviet Union's first swing-wing bomber. When NATO officials learned of its existence in 1969, they gave it the codename Backfire. At the time, it appeared to be the elusive long-range supersonic bomber the Soviets had been trying to build for nearly 15 years. In the late 60s, Western observers surmised the Backfire was an updated version of the Blinder, modified with swing wings. This assumption was based on the often confusing system of Soviet aircraft designations. The Blinder was the Tu-22, and the new swept-wing bomber was the Tu-22M. Naturally, the West assumed the M was a modified version. But this wasn't the case. In fact, the Tu-22M was a completely new aircraft. Andrei Tupolev had begun development on his own back in 1964. Because the government hadn't asked for the bomber, it was easier for him to use an existing designation. Tupolev later said that disguise as mere modification was political. The first-generation Backfire was not a major improvement over the Blinder. It wasn't until the aircraft was redesigned that it posed a significant threat to the West. The new bomber was designated Tu-22M-3. Westerners called it the Backfire B. For a bomber, the Backfire's engine placement is strange. In many ways, it looks more like a fighter than a bomber. Most bombers reserve the fuselage for fuel and payload. The Backfire's engine and intakes occupy fuselage space. So when it carries a heavy weapons load, it needs to reduce fuel, thereby reducing range. When the Backfire entered service with the Red Air Force in the early 70s, it had a refueling probe on the nose. This made the Pentagon extremely nervous. American military officials were certain that the Soviets now had a supersonic bomber which could reach North America. The Soviets maintained that the Backfire was not an intercontinental bomber, but rather a tactical bomber for use in Europe and Asia, with a range of under 1,500 miles. During the Strategic Arms Limitation talks in 1975, the backfire became the subject of heated discussion. America was skeptical of Soviet claims that its swept-wing aircraft was not an intercontinental bomber. In the end, the Soviets agreed to remove the refueling probes. By the 80s, it was determined that the backfire had a radius of action of only about 2,000 miles, with a nominal bomb load. Nevertheless, the backfire remained a potent weapon in the Soviet arsenal. It could carry over 26,000 pounds of bombs, both nuclear or conventional. It could also carry 2 Kitchen air-to-surface missiles. For many years, the backfire's range was debated by defense intelligence in the West. So was the question of whether or not it was really a strategic bomber. Either way, it was certainly the shape of things to come. In December 1974, a revolutionary American bomber took to the skies over the Mojave Desert. It was the Rockwell B-1. The B-1 was designed to penetrate Soviet airspace under the radar. Soviet air defenses were geared towards the high-flying subsonic B-52, so the emergence of the B-1 made quite an impression. It was a true supersonic intercontinental bomber, an aircraft the Soviets had been trying to design for over 20 years. In November 1981, a crude American reconnaissance photograph revealed a new bomber operating from the Romanskaya Flight Test Center. Defense intelligence immediately noted its similarity to the B-1. But the new Soviet bomber was much larger. In fact, it was even larger than the massive B-52. NATO gave it the codename Blackjack. Behind the Iron Curtain, it received the designation Tu-160. The Soviet Union finally had the intercontinental strategic bomber it had been looking for. The Blackjack remains the heaviest, most powerful combat aircraft in history. The Kuznetsov NK-321 turbofans are the most powerful military engines ever flown. With 4 mounted in paired nacelles within the inner wing, the Tu-160 has almost 80% more installed engine power than the B-1 and is nearly twice as fast at high altitude. Although it's 20% larger than its American counterpart, the Tu-160 has a smaller radar cross-section and less aerodynamic drag. Its unrefueled combat radius was over 4,500 miles, more than the B-1 and almost twice as much as the backfire. But all of this came at great cost. Red Air Force Colonel Yevgeny Vlasov eventually told Western journalists that the Tu-160 was an expensive countermeasure. Although the exact figures are vague, it was clearly the most expensive Soviet aircraft program of the Cold War. In 1988, the Soviet Union was planning to build 30 aircraft a year into the 1990s. In the spirit of perestroika, the Soviets invited Western military officials to inspect their powerful new bomber. The group, which included the U.S. Secretary of Defense, quickly realized they were looking at a formidable weapon. But by now, such an aircraft was considered more of a technical achievement than a potential threat. The Cold War was drawing to a close, and so was the race to produce faster, more potent nuclear bombers. The Tu-160 Blackjack was the ultimate Soviet bomber, and it would also be the last. Having struggled for so many years to build a successful intercontinental bomber, the project fell victim to thawing relations between East and West. Ironically, it was the same improving relations that had Soviet designers taking another look at their Blackjack. When the Tu-144LL was rolled out to begin a series of research flights, the Blackjack's powerful engines were brought back to life. With a series of test flights in Russia, NASA and Boeing are hoping to uncover the problems of sustained Mach 2 flight. The ultimate goal is creating the passenger aircraft of the 21st century. Today, engineers are looking to the future with technology from the past, and in so doing may give Andrei Tupolev a legacy he had never imagined.
Coming up next, Discovery Wings Channel celebrates the golden age of flight. Look back on the spectacular successes and the devastating failures that changed flying forever. Centennial of Flight, part of our year-long celebration. Coming up next on the Discovery Wings Channel.